Hi students, இந்த வீடியோ கிளாஸ்ல நம்ம சொல்யூஷன் சாப்டர்ல colligative properties ஒரு ஸ்மால் ட்ரிக் ஒரு ஈஸி அண்டர்ஸ்டாண்டிங்கும் அதே மாதிரி ப்ராப்ளம்ஸ் எப்படி சால்வ் பண்ணலாம் ஈஸியா அப்படிங்கிறதுக்கான ஒரு ஹிண்ட்ஸ் தான் பார்க்க போறோம். ஸோ இதில் பார்த்தீங்க அப்படின்னா we know what the colligative property இல்லையா, the properties of solution which depends on number of solute particles. Am I right? Which depends on number of solute particles. So those properties are said to be colligative properties. Am I right? Yeah. So here we have four colligative properties: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So under RLVP, relative lowering of vapor pressure, we know the expression, isn't it? Another delta P divided by P naught is equal to I into Van't factor I into mole fraction of solute. So இப்போ பாருங்க, delta P, what is the expansion அப்படின்னு பார்த்தோம்னா vapor pressure of pure solvent minus vapor pressure of solution இல்லையா. நம்மளுக்கு ஏற்கனவே ஒரு key formula தெரியும், I mean key relation தெரியும். என்ன அப்படின்னா boiling point is inversely proportional to vapor pressure. Am I right children? So இப்போ pure solventக்கும் solution, அதாவது solvent plus soluteக்கும் நம்ம boiling point compare பண்ணா boiling point of solvent பார்த்தீங்கன்னா லோவரா இருக்கும், ஆனா boiling point of solutions ஹையரா இருக்கும். இது நம்மளுக்கு தெரிஞ்சது. இதுவே in terms of vapor pressureல சொல்லணும்னா see boiling point of solute, I mean solution is always greater than boiling point of solvent. In terms of vapor pressure எழுதணும்னா என்ன பண்ணுவோம், they are inversely proportional னு சொல்லிருக்கோம் இல்லையா. So here I can write vapor pressure of solution is less than vapor pressure of pure solvent. Am I right? That is why I can say when you increase, solution is what basically solute plus solvent. When I increase the number of solute particles, okay, when I increase the number of solute particles, this delta P, which is nothing but P naught minus Ps, the vapor pressure of solution, when I increase the solute, the vapor pressure of solution decreases, okay, whereas the vapor pressure of P naught increases. So in over I can say delta P, that is change in vapor pressure of pure solvent and solution will increases. So this colligative property, what I can say, when you increase the number of solute, delta P increases. So I can come to the conclusion delta P increases. Okay, and similarly if I go for elevation in boiling point, here I can say delta TB is expanded as boiling point of solution minus boiling point of pure solvent. Just now we said the boiling point of solution is greater whereas the boiling point of solvent is lower, and hence when I increase the boiling point of solution, then number of solute particles in the solution increases. Okay, this delta TB also, delta TB elevation in boiling point also increases. Okay, if we move to depression and freezing point, we can say that, see here delta TF, when I write expand them and write, I can write TF not always the freezing point of solvent is greater than the freezing point of solution. Am I right? So if I take this one, it is very clear here TB is greater than TB naught, whereas in this case I can say TF naught is greater than TF, that TF naught is the freezing point of pure solvent and TF is the freezing point of solution. Okay, this is much greater. When this value increases, we know very well delta TF increases. Delta TF increases. Okay, when I move to osmotic pressure, here we can see when number of solute particle increases, this osmotic pressure, which is directly proportional to each other, they will also increases. So I can come to a conclusion that when in a colligative properties, if you consider these colligative properties, when number of solute present in the solution increases, I can see delta P increases, then delta TB increases, and delta TF increases. Similarly, osmotic pressure also increases. See all these delta P, delta TB, delta TF and pi value increases. Whereas if you consider this, see when number of solid particle increases, the boiling point of solution is greater than the boiling point of solvent. You don't forget this. See, this I can conclude. So those who have little confusion, I think if you study like this, it is very quite clear while solving the problem. See, when I take RLBP, this vapor pressure of solution, that is solution which is lesser, whereas total delta P value increases. In this case, the boiling point of solution is greater, whereas the boiling point of solvent, which is always lower compared to solution. Here, I can say the boiling point, see the boiling point of solution increases. Here, vapor pressure of solvent increases. Okay? Here, these two increases. Whereas here, delta TF increases. What it does mean to us? Delta TF naught, freezing point of pure solvent increases. Here pi value, whenever I factor and concentration increases, that is number of solid particles increases, this pi value also increases. So whenever you study these colligative properties, keep this trick in mind. Very easy point that vapor pressure of solvent increases, delta P increases. And here boiling point of solution increases, delta TB increases. When this delta TF increases, if TF not increases, and when concentration increases, pi increases. These points are very simple points. However, while solving the problem, this much clarity must be always in your mind.